This MQTT connection just got rejected by MQTT broker. Not because the server is down or the password is wrong, but because this device couldn't authenticate itself with certificate. Now watch what happens when it can prove itself. Most MQTT tutorials stop at username and password. And in production, that's not the authentication we use. Hello everyone, I'm Hariharnath and welcome to IoT Frontier. Today, we'll be looking into how to secure MQTT with TLS certificates using professional and scalable approach. For the first time, this process will be looking like a complicated one, but stick around until the end to completely understand this process. So here you can see in the diagram, first we'll be creating private CA certificate, and then we will be creating server certificates for MQTT broker and client certificates for ESP32 and Node-RED. And we'll be looking how we exchange the certificates and how it is authenticated and we can connect to MQTT broker successfully. For this tutorial, we'll be using ESP32, but we will not be using any sensor, but we'll be sending simulated values to the MQTT broker. So now let's start with creating of these certificates. So before we proceed to create the certificates, we have to install something called Git Desktop for Windows users. So if you're Linux users, you don't need this Git Desktop, but for Windows, you would need this so that it will install OpenSSL and other related things that are needed for creating the certificate. So you can directly go to this website and then download. So once you have downloaded, you will be seeing something like this. So if you search for Git, you will be having bash and cmd, etc. We need to open git bash because there are few commands which needs to be similar for both Windows and Linux. That's why I'll be using and recommending this git bash. So once you download this, you need to first create a directory and then get into that directory. So now I have created this directory. We'll create the CA certificate. So first we have created CA private key, and then we'll first export one of the important variable so that there won't be any issue that we are going to face in Windows. So this will make sure it will not do any kind of conversions of any arguments. So next we create self-signed CA certificate from this CA key. So in the subject we see we have created country, state, and then all the details which are needed. You can customize this and then enter. So if you don't see error, then it is working. So next is server key. So that is for MQTT broker. So we create this server key and then we generate the broker certificate signing request, that is CSR, using that key. So after that, we have to sign this broker certificate with our CA. So to do that, there are two steps here. First is we need to export another value. So then I'll use this OpenSSL command so that it will sign the server CSR. So self signature is okay and it has been completed. So after that, we need to create ESP32, that is client private key. And then we need to create again the client CSR file. So here we need to provide certificate name as ESP32 device 01. And before this, I would like to add one more point to the previous step. So here if you see, we are adding one external file that is having the mosquitto broker as DNS, and inside that we are trying to put multiple values. So one is for local host, another is your IP address of your laptop, because if you don't provide this IP address of your laptop or this local host, then there would be some issue that you will not be able to connect. So for ESP32, it has to identify using this IP address, and for locally, if you are checking, local host will work. So you need to use and modify this IP when you are trying to check. So coming back to this, so you are trying to create ESP32. So now you have created ESP32 device client certificate. So CSR has been generated and now we'll sign that with our CA. So this has been signed now. So if you understand clearly, every certificate is tracing back to ca.crt and ca.key. So that's the most important and sensitive file in your project. And in production, this file lives in the hardware security module or an offline vault. So it should not be put in any of the broker or third party so that you should not lose it. So the certificate generation is completed. Certs_new is the new folder I have asked to create. So now we can see all 10 files has been created. Next thing is we need to set up our Mosquitto broker. So you need to download from here, and if you want to have full step-by-step video for this, then you can check my previous video where I have installed it on Windows. So once the Mosquitto broker is installed, you need to open Mosquitto folder. So it would be under your C program files Mosquitto, that is the default path, and inside that you will be able to see mosquitto.conf. So you need to edit it. So you can edit with Notepad or Notepad++. So inside that you need to add, these are the different values you need to modify. So I have provided this as a bulk, and you can delete the rest of the document. So inside Mosquitto there are some files. So we need to first copy them. So inside Mosquitto I have created this folder, that is certs. So from certs_new I am going to copy a few of them. So first is ca.crt, server.crt and server.key. So now I am going to copy them, and you need to verify the path. All three are available, and then so these are the different values you need to set. So once that is done, you need to restart your Mosquitto broker. So for that you can use net stop Mosquitto. So if it is already there, it will stop. For me it was not there. So once you have stopped it, you can manually start using this mosquitto-c mosquitto.conf-v, so that we can see all the values, whether it is errors or some kind of success messages directly here. Now to verify this certificates are working with this MQTT broker, you can go to another command prompt and paste this test command. So here you can see it is trying to connect with localhost with 888.3 and CA file and the certificate as well. So once you execute this, so in the first tab you can see the proper messages of acknowledgement, and you will not see any error here, which means it is properly working. So you can close this with Ctrl+C, and here you can see it is auto disconnected. Now let's look into the real world scenario where we are going to use ESP32 as a client. So for that I'll connect my ESP32 to the laptop, and I'll not be connecting any sensor here. So once connected, I can see it has been set to ESP32 dev module automatically. You can also set whichever the COM port that is available for you, and then make sure you have pub/sub client in the library manager, and then modify the SSID password, and here the MQTT server should be your IP address of your laptop. You can modify this, and then from the ca.cert file you need to copy and paste the certificate file here. So that is very important here. So once you paste that ca.cert file, you are ready to go. And here this is just a basic program to simulate the temperature values. So now I'll simply upload this. So now you can see the Wi-Fi has been connected from the serial monitor, and it is even connected to MQTT S broker, and you can see 26.6, and it is trying to send all these values. So we can monitor them from this MQTT broker as well. So you can see from the MQTT broker the device values are getting displayed here like publish messages, which means that the server side certificate is authenticated properly. So this is the process that we have seen is like server side TLS only. So now let's look into what has happened in the details. So this is the flow chart that you can see. So ESP32 Mosquitto broker and Node-RED. So these are the three different things that we will be seeing. So Node-RED as of now I haven't connected, but if you understand the first step, that is ESP32 and Mosquitto broker. From ESP32 we are sending TCP connect, and then the server Mosquitto broker sends the response as server hello, and then our ESP32 will verify the server certificate against the CA certificate that we have pasted it. So we have pasted that CA certificate in this code, and using this CA certificate it will check the server certificate is valid or not, and based on that the TLS handshake is completed, and our MQTT client will be connected to the broker and connection will be established, and we are sending the published temperature readings every time. And what if we are also wanted to check the client certificate by the Mosquitto broker or the server. So we want to avoid any malicious client to be connected to our broker or server. So to enable that, we need to enable Mutual TLS. So now in the next step, we'll do that so that even Mosquitto broker will check the certificate of ESP32. First, you need to go to your mosquitto.conf. So here, first thing is you need to make sure you enable this use identity as username true, allow anonymous as false, and most important is require certificate as true. So this will make sure that we present client certificate as well. So which enables our mTLS. So these three changes you need to make and save it. Now we can restart our MQTT broker. So now you can see it has been restarted. Before I proceed further, if you haven't subscribed to our channel yet, please subscribe and hit the bell icon as it helps us to keep producing good content for you. Now that we have enforced mTLS in the mosquitto.conf, we are seeing some errors in the Mosquitto server. So what we have to do is we have to modify our ESP32 code to present our client certificate as well. So first we have presented only the ca.cert. Now we have to present client.cert and client.key. So both of them we have to embed in our code, and then in the setup also we need to mention them as here. Upload this code. So now we can see the Wi-Fi is connected and even the MQTT broker is connected without any error. And we can also check from the MQTT broker logs. New client is connected, the IP address of your ESP32 device as well. And now it is trying to send the values as well, that is visible. So now we want somebody to subscribe to these messages, right? So that's where our Node-RED will come into picture. So first you need to start Node-RED. So I'll just open Node-RED. So if you don't have Node-RED installed, you can look into my previous video where I have explained step by step. So now I'll go to the Node-RED. So first I'll try to create a new flow. So you can drag and drop the MQTT in and then a debug node first, and then we can also have a UI. So in the UI we can drag and drop the gauge. So first I'll connect that as well as debug. So we have to configure this MQTT. So inside that we need to provide our local host with TLS certificates and all. So first you need to click on plus icon and give a name as localhost TLS. For me I can just put as new because I already have one. So here I can use localhost or your IP address, and here you can use TLS, and in this use TLS you need to add the certificate chain. So for that you need to click on plus. So here you need to select individual files and click on this use key and certificate from local files so that you don't have to upload them again. So for this we have to create a new certificate chain again, because for Node-RED we haven't created yet. So we'll go first to again our git bash. I'm going to create Node-RED client.key and it will generate Node-RED client key, and then the CSR file for this is created. Next we sign that CSR with ca.cert. Now you should be finding this under your certs new. So you can see this Node-RED client certificate is available. So you can copy this location where your files are generated and then provide the path. So I'll just append with the proper values, that is Node-RED client.crt, and I'll add the rest of them. So this is the private key. So I'll just name it as .key, and here the ca.cert is needed, ca.crt. And we can just add now. And under security and messages you can leave them blank. So this port has to be 8883 and click on add. Now the topic has to be provided. So that is IoT Frontier / TLS demo, and QoS I can just keep it as 1 and click on done. So now I'll just deploy this and confirm. Now we can see the green dot, which means it is connected. I can also check in our MQTT broker that we have new connection. And also in Node-RED you can see the connection has been successful, and we can see the values as well, 38.4. Now we can set up the gauge, add a new gauge with new tab. So in the gauge node you need to modify this value format. So I'll use message.payload.temperature. So because you can see in the object message.payload temperature we want to show. So that's why I'll put that here, and the range should be minimum, that is 0 and 50. So this way we can show the important values in that range. So click on done, deploy. So once deployed, you can open a new tab, and here you can use /UI with the same address. You can see the gauge is already showing the value. So that gauge moving live is the proof of MQTT secure TLS authentication working end to end. So now I can show you what has happened completely. So this is the flow chart. ESP32 is trying to do the TCP connection, and then it has given the server certificate. So even the server has requested certificate. Now it has to present a valid certificate. When it presents, it will send that ESP32 client.crt, and it will verify against the CA that it has, and then it will send the TLS handshake complete. Then only we will be connecting to MQTT and we can be publishing. In the alternate case where the certificate is not presented, we were seeing previously the connection rejected. That was one phase of communication from ESP32 to MQTT broker. Now if we talk about Node-RED, so Node-RED also similar condition, where for Node-RED also the MQTT broker has requested the certificate. Then we send this Node-RED.client certificate, it will verify, and then only we will be able to see the publishing or subscribing happens. So if you found this video informative, please type helpful and smash that like button. If you wanted to learn IoT from scratch, then you can check out my course on Udemy from the link in the end screen and description. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.